Jumping right into our logarithm crash course, pay careful attention. So we're going to start with a variable in the exponents. So here we have our rewritten form from exponential form to logarithmic form. The first two problems, it was just as simple as that using the definition of logarithms, whereas the second two problems, we had to isolate our variable first by adding 4 to both sides or adding 1 to both sides. And second, after we rewrote it in logarithmic form, we had to divide by the coefficient of the variable in order to simplify. I went ahead and set the arguments equal to each other. Then you just solve algebraically. Same thing here. These ones are a little different. They don't have a log on both sides. So you go ahead, just divide, isolate the variable, and continue that way. Here we have adding and subtracting logs. When you're adding two logs together of the same base, you go ahead and multiply their arguments. As you can see here, I had log of x plus log of 3 is equal to 2, which is going to turn into my power of the base 10 after I convert it or condense it from two separate logs into one individual log of 3x, 3 times x, still equal to 2, convert it from logarithmic form into exponential form. The base 10 to the second power is now equal to 3x, and you can just simplify that to 100 over 3, or your decimal 33.3 repeating. Same thing here, I multiplied again because I'm adding two logs of the same base together. You can simplify that one step further as well. The opposite is true when you take logs of the same base and you subtract them from one another. Instead of multiplying, you will divide. So my first example involves 2x squared, and then I'm taking away log base 9 of 8. So I set those into a fraction 2x squared over 8, which you can simplify into x squared over 4, or if you would prefer to multiply 81 by 8 and then divide by 2 a second time, you'll end up with plus or minus 18 when you take the square root of 324. And finally, for our last question here, we're still subtracting, which means it's going to turn into a division problem within the argument of our log, base 10, which means 10 to the first power will be just 10, and our argument, so we'll multiply in order to solve for the variable x. So our next one, we're going to learn how to condense our arguments. All right, so now we're taking our condensed logs, our initial problems here, after we added or subtracted them, multiplied or divided them respectively. We're going to go ahead and expand it back out. So I have log base 4 of xyz squared, so I can go ahead and make it into addition between all the same base with that argument. This 2 comes from z squared. As you can see, we also have a to the 6th power b cubed, so the exponents turned into the coefficients of the log. Because I divided them, I had to subtract here. If you remember your rational exponents, you have x to the exponent over index, so something like the square root of x turns into the 1/2 power, so that's how 1/2 comes out from log of the square root of x when we're looking to expand our logarithms. And lastly, if I have log of x to the 5th power, it's going to turn into 5 log x. All right, so now I've gone ahead and put together one quick practice problem that combines all the skills we've learned so far with expanding logarithms. So if we have something with the cube root of u times x to the 5th power, we know it's going to turn into the 1/3 and the 5th coefficients in front of the log, and then divided by y squared, well, we have minus 2 log y. All right, you're about to need to pause the video because I have some practice problems here. That way you can get enough practice required on these particular topics of expanding logarithms and just understanding how they all work. So go ahead and pause the video now. This is also some practice problems. These ones you're going to need to use your calculator to approximate. For base 10, you just press the log button, whatever number you're trying to calculate, and then estimate to the nearest 10,000th place. Our last part of our logarithm crash course today is finding the inverse of a logarithm. So as usual, we have to switch the x and the y. And then what you're going to do is divide, in this particular case, by -2. That way we can go ahead and isolate the variable y as much as possible. You convert it then from logarithmic form back to exponential form, and you're left with your answer here. 3 to the power of x over 2, or negative x over 2, is equal to y. In the same case that we did all that work, right here, our base was 10 to the power of x over 4 after we divided by 4, and of course switched our x and y at the beginning. I left some work for you guys to do with these problems, but you do the same process. Again, you want to isolate the variable y that you're solving for after switching places with x and y to find the inverse, because if you were representing it visually, you'd be reflecting your exponential graph or your logarithmic graph over the line y equals x on the coordinate plane. So I left some work for you guys to do in these last couple, so go ahead and take a look. Hope you enjoyed today's crash course on logarithms.